Hey guys, in this video we'll be looking at creating an architecture like this where we'll publish a message to an SNS topic and filter those messages through a priority. Based on the priority, let's say high and low, either of two lambdas will be triggered. So we'll be looking at a concept called message filtering provided by SNS topics. If you aren't already familiar, AWS CDK or AWS Cloud Development Kit allows you to create resources in AWS using familiar programming languages like TypeScript. AWS SNS is a service, a pub sub service that allows you to create or send messages between services, let's say in a microservices environment, or send out notifications via email, SMS, and any other notification subscription platform that you may be familiar with using Lambdas. AWS Lambda is a serverless compute platform that allows you to write business logic in pretty much any language at this point and then deploy them to AWS Cloud without you having to manage those resources. I have an empty directory here for the project. The first thing I'm going to do is initialize a CDK application using the TypeScript language. The JSON flag here tells CDK to output any CloudFormation templates using JSON instead of YAML. While this is doing its thing, let's go look at the CloudFormation stack and you'll see that there's nothing here. This is important because just after this step, we'll actually do a bootstrapping step through CDK Bootstrap. And this allows CDK to set up some initial resources for managing its own lifecycle. One of the many things it creates is an S3 bucket, some IAM rules to execute resources created in those templates. So let's have a look real quick. If we go over to the resources tab, you will see that it's creating some secrets, some IAM roles, and soon, and you can also see that it's creating the S3 bucket. If you're really interested in seeing all of the resources that go into this bootstrapping process, I encourage you to try this by yourselves and also peruse the documentation here. All right, now that that's done, let me just clear my terminal. We'll open this up in VS Code. Okay, we can see here that we have a bare bones CDK application with some comments. I'm going to get rid of those. The first thing we want to do, going back to the diagram, is we want to create the SNS topic. So let's say, for example, in this application, we want to create a notifications. We want to send out notifications for orders that are placed by our customers. So the first thing I'll import is SNS from CDK's library SNS. And the way we can create one is, let me just call this the order notifications topic. We say new SNS.topic, give this as the construct. Every construct that you create in CDK requires an identifier, so I'll call this order notifications topic. Copy that and pass in a bunch of properties. Here we'll say the topic name is order notifications topic once again, and by default first in first out is false, but I'm going to specify here it anyway, just for completeness. The next thing that we want is a lambda. So I'm going to follow a directory convention here for creating the lambda, and I'm going to go within lib, call it lambda, and within that, since we need two lambdas, one for high priority notifications and one for low priority notifications, I'm going to create two directories. So let's call them high priority lambda and another for low priority lambda. And we'll see how we can use this in just a few minutes. Within each of these, I'll create a source directory within which I'll create an index.js file. All of our lambdas today will be written in JavaScript. And so a single index.js file. I'll go ahead and do the same thing for the other lambda as well. Finally, we'll export a handler function. And so we'll say exports.handler is an async function. And every event handler that uses SNS as the event source gets the event itself, a context object, and a callback. The callback really is used to return a response once the invocation is done. Since we are using async await, we can return a promise, and Lambda will take care of resolving that promise for us. So I'll get rid of the callback and the context since we don't really care about it. Finally, I will just console.log that the event happened. So we are in the high priority Lambda, and we'll call it the event, and we'll stringify the event. I'm going to do the same thing for the low priority Lambda as well. Come into source index.js, paste in the bit of code, and just change this to low priority Lambda. Now that we have the Lambdas out of the way, we actually need to create the resources in AWS. So I'm going to import Lambda from the CDK library. So let's create a high priority Lambda is a lambda.function. The identifier is going to be high priority Lambda. And this is going to take a few properties. First thing we want to tell Lambda is that we are going to use the Node.js runtime. So Lambda runtime Node.js. Second, we need to tell it where our code lives. We'll come back to this in a second. And finally, it expects us to specify what function to run. So it takes a handler property, and in our case, we named it the file name, and the handler function's name is handler. It's a fairly common convention to follow. So I'm going to say index.handler. Let's finally specify the path where we can find this. So quickly import path from path. This comes from Node.js standard library. Oops. All right. So I'm going to say the high priority Lambda path is resolve in the current directory, go into the Lambda directory, high priority Lambda, and then source. And then here I can say lambda.code from asset, and then I give it the high priority Lambda path. So this essentially tells Lambda that you can find all of the source code within this directory, and you can find the actual function within a file called index.js, specifically execute a function called handler. I'll go ahead and do the same thing for the low priority Lambda as well. The next thing to do is connect the auto notifications topic and the Lambdas. SNS topics allow us to subscribe to messages using multiple subscriptions. The one we'll use today is called a Lambda subscription. So we will say auto notifications topic, add subscription, and here what we want is a Lambda subscription. This comes out of the SNS subscriptions package from CDK library. The only argument that's required here is the name of the Lambda. So we'll give it the high priority Lambda, and that should be good. Finally, we'll add another for our low priority Lambda. I'm going to change over to the browser real quick before we deploy this to show you that nothing exists. So coming back to a stack, we have the bootstrap stack for CDK, nothing else. If we went into SNS, I'll open that up in a new tab. You'll find that we have no topics, and let's quickly look at Lambda as well. Come in here, go to functions, and we have nothing here. So at the end of this process, let me switch back to my terminal and say CDK deploy using my profile. So it does a couple of things. The first thing it does is synthesize, which means it takes all of the TypeScript code that we've written and create CloudFormation templates out of it. And then finally, it tells me a summary of what it's going to create. So these are the statements it's going to create, and I'm going to confirm that those changes are what I need. If I switch back to the browser real quick, you should see a CloudFormation stack being created. There you go. SNS Lambda stack, and it's in create in progress. You'll see a few different resources. You'll see some metadata that it stores, the order notifications topic itself, and the two lambdas. Let's look at SNS, refresh the page, and the notifications topic is created. How about the lambdas? Not yet. So it looks like it's still doing that. All right, now that we're done, we should have the lambda and the subscription created. You can see two lambdas created, and refresh the page, and the two subscriptions are here as well, the high priority and the low priority. Let's just quickly publish a message to see how this works. Let's say test message. Notice that this is optional, you don't need to provide this, and we'll say hello world. Ideally, if everything worked well, we should see two invocations, one for the high priority lambda. Let's open up CloudWatch logs, and let's quickly open up the low priority lambda as well. So here we see there was an invocation, and this correctly spits out the event that came through. Notice here for a second a certain structure that SNS pushes as the event data. It has a records array with a single record, and the type is notification. The subject is test as we provided, and the message is JSON stringified. Similarly, for the low priority lambda also, we have another record logged here. Ideally, what we want is to be able to split this from our architecture diagram here. We want to be able to conditionally trigger these. Maybe there's a VIP customer for whom orders get sent out first, and then for non-VIP members, the order delivery is delayed in a hypothetical situation. So the way we would achieve this is through message filtering. There are two types of filter policies that you can apply to SNS messages. One is for the attributes, and one is for the payload itself. For message attributes, you can think of these as metadata attached to a message. So say we have, for example, a message with hello world. You can attach metadata to the message itself, maybe a customer ID, maybe their interests, etc. When you attach metadata to a message, it is part of a message attribute key in the SNS event payload. Let's take a look. Some metadata, and let's say John Doe. In fact, let's actually make this a little more meaningful and say the username. If we were to publish this message now and look at any one of our lambdas, let's go to CloudFormation. You will see that message attributes are part of the payload. So filter policies by default, going back to the topic, we can set filter policies at a subscription level, and by default a subscription filter policy applies the filtering logic to the message attributes. What we want is to provide filtering at the message body. Let's see how we can do that. Coming back to our CDK code, let's add a filter policy for the message body. We'll look for a key called priority, and we'll say that the filter policy to be applied, it's a filter. We'll say it's going to be a subscription filter, it's going to be a string filter, and we'll allow the high priority. So any message that comes in to the topic with the priority key set to high will be routed to the high priority lambda. Let's do the same thing for the low priority lambda as well. I'll copy that over, and we'll say, oops, low. Let's deploy this. CDK deploy. If we look at our subscriptions again, you will see that a message body filter policy has been applied correctly to both the subscriptions. Let's now publish a message and see what happens. We would expect that any keys with, let's say, order ID 123, any messages with the key of priority high will be routed to the high priority Lambda. Going back to the high priority Lambda log group, just quickly refresh. You can see that the priority high message came through. And to prove to you that low priority Lambda was not triggered, you can see here the only message from earlier where we included message attributes. And as you'd expect, if we were to create another message with a low priority, that would get routed correctly to the correct Lambda function. Coming back here, let's refresh our log group, and you'll see that the low priority Lambda came through. If you are following along, make sure that you tear down the environment. You don't want to leave resources hanging there and get built unnecessarily. So I'm going to say CDK destroy with this profile, and it should bring down all of the resources that it created. That's it for this video. If you liked it, please hit that like button and leave your comments down below if I missed something or if you'd like me to cover more AWS related content. See you next time.